Welcome everyone to another installment of Solidworks Live Design. I'm Mark, I'll be your host for today, and I'm coming from San Diego, California. I've seen in some of the previous live designs some of the other people do this kind of Google Earth thing, so I thought, hey, why not just follow suit and do the same thing? So this is where I live in San Diego. I see in the chat that we have quite a few people from a lot of different places here. I see Latvia showing up, as well as Manitoba, Canada, from all over the place. So thanks everyone for joining us today for another live design event. This is, like I said, the 13th, so we've done quite a few of these so far. If you haven't seen the ones in the past, definitely take a look at the description in the video, and then you can kind of check out some of our other live designs. So for example, last week Steve showed us how to make a DIY planter box, and that was a really cool and actually useful live design that we did. Andrew before that showed us how to design the ambiguous cylinder, which is sort of like an optical illusion, but it's physical and it's really cool. He showed us how to make one of those in SolidWorks. And a couple weeks before that, Juan showed us how to make a pergola. He wanted to create a pergola off the back of his house. And so he used SolidWorks weldments to do that. So a lot of like really cool designs, and that's just only a handful of them. So definitely check out some of our previous live designs if you haven't seen them. This one actually kind of builds on a lot of those other ones, so it's going to be a little more advanced. But I think you'll still be able to get a lot out of this. So, but we have a lot to do today. So, what are we going to be talking about today? It's going to be the secret behind the best designs. I say that as if there's only one. Of course, there's many, I guess you could say, secrets, behind designing really well. If you have a secret that behind how you design, or maybe a cool tip or something, put that in the chat and let us hear it, or in the comments below the video. Let us know what you think one of your best secrets to the best designs are. But for me, I'm going to talk about something that I think has really helped me improve my designs and make me not only just a better CAD jockey, I guess, but just a better engineer in general. And so we're going to talk about that today. So let's talk about quickly what the best designs are. So when I think about best designs, I think about things that are pleasant to use on a daily basis. Something that I always grab for, and we all do, we have like our cell phones. It's something that's a really great design these days. It's just a big screen, it's nice curved edges, that sort of thing. So I think a lot of people would agree that that's a really good design. Just looking at things on my desk, I have a mouse here that I think is done really well. This is it's just one kind of shape, but it's very ergonomic and it's got some cool design elements to it. And I think something like that is really neat. Another example, this one's kind of not a super exciting example, but this is just kind of a case for some tools that you can use, but it's got like kind of these magnetic snaps to it, and I think that's a really cool design as well. Notice that this is a very intentional design. They've decided to create this nice edge here rather than it being being some kind of overlap or something like that. Somebody really had to take some time and effort to do that. Here's one of my favorites as well. This is just a remote game controller, and this is I think a pretty neat example. But it doesn't always have to be something like that. It could just be something that's a really good tool for the job. I was trying to rip up the deck in the back of my house, and I started with just the tools that I had on hand, which was like this little tiny pry bar, and there's just no way I was going to be able to do the job with that. So I had to go to the hardware store and get a really big pry bar that would actually give me some leverage and help me get the boards off the deck. So a good design doesn't always have to be something like this, but I think sort of these products are really an interesting example because they're a really they're just a good example of something that's like very ergonomic, very well done. But I want to talk about sort of how these things are made, because when you look at it, if you break this thing apart, notice here I've pulled off one of these panels on the back. Notice that this is actually an assembly of several different components So here you can see that once you snap all these together, they make this really nice smooth edge. So when you're playing video games for hours like you're not supposed to, you can your hands don't get cut by little jagged pieces of plastic. So that's a really advanced example, and I didn't want to go into doing something super advanced. We only have about an hour. So something that I use every day that I think is really pleasant is this. And this is a home automation remote. It's something that you can use to automate tasks around your house. So if you want to turn on your sprinkler system, you can press a button. If you want to cycle the music, you can press another button. If you want to turn the music up, you can press another button. And you can use this to just automate tasks around your home. It's programmable and it's wireless. And so if I want to turn on like a little desk lamp, I can hit this button, and now I have a little bit more light in my office. If I want to turn that off, I can press a button and it goes off. So, this is something that I find pleasant to use, and I use it on a daily basis. And I want to just kind of talk about how this was designed from start to finish, because it's great to be a designer and to be really good at CAD, but there's a lot more elements to it. So this design started with somebody that just thought of something in their head. They said this would be a really smart idea, but they have to go through a lot of different processes. So they come up with some sketches, and maybe they even go to the lengths of making something like this or having it done for them by an industrial designer. I didn't draw this. I wish I did. This is actually courtesy of my brother, who has a lot of real talent in this area. So so somebody might sketch up something like this, and then you may go into the CAD of your choice, Solidworks, for example, and start making these parts. And then after that, they all have to be manufactured. So in this case, I'll just open up this thing real quick. I've got a little tool to pop this open. There we go. And so we can see it just comes into two halves. We have these two halves here, and there's a little circuit board in there with a battery and some buttons. And we'll just put that to the side. But for the most part, it's just two pieces of wood milled out, and then we have some buttons here as well. So that's a relatively simple design, but there's a lot that goes into making something like this. So let's talk about that. Let's talk about how we would perform this in SolidWorks. And the method that I would recommend would be something called master modeling. And there are several ways that you can do this inside SolidWorks, and so we'll go through some of them. So before we get started with that, I'm going to quickly check the chat, just see how everything's going here. Oh wow, okay, Mauritius, the island of Mauritius, beautiful place. Nigeria as well, wonderful. Thanks everyone for joining. Hello everyone that I've seen here in just about every episode, Mr. Oogly Boogly and Eric Beatty and the lot. So thanks everyone for joining us. Okay, I really like SolidWorks, a flexible software. I agree. Thanks, Infant Nelson. That's exactly my thoughts too. All right. You're telling me to keep calm and not shake my hand. Sorry, this is the first one I've done, so I'm trying my best. Let me see if I can get these a little bit steadier. All right. Just shaking off the nerves. So, okay, cool. So let's get started with this design in SolidWorks. Now, something that I want you to pay attention to with this drawing is notice that there's something missing from here. This drawing has no dimensions whatsoever. There's not a dimension on there, and of course that makes sense. At the beginning of a design process, we may not have that information. So let's take a look at SolidWorks and let's get started with our design. I'm going to go through three master modeling techniques with you today, and I'll kind of go through the pros and the cons of them. And then after that, I'll talk about what I think is the secret to the best design. So let's get started. I'm going to use a millimeter template here. Okay, and I'm just going to get started by sketching on the top plane, and I'm going to use my S key. This is a shortcut key, and we've seen this highlighted in a lot of previous live designs. So I'll grab my rectangle tool, and I'm good with that. I want to make these two lines equal to each other because I want to create a square. So I'm going to select over both of those and make them equal using this convenient pop-up that shows up here. Now keep in mind that I did a right to left selection rather than a left to right. A left to right selection will only select things fully within that box. So for example, that line there. But a right to left selection of the same thing we'll choose anything that's in the box and anything that crosses it. So that's a nice little tip there. Something else I'm going to do here is another quick shortcut, this auto insert dimension. Rather than trying to grab my dimension tool, I'm just going to use this pop-up. It's going to put it on there and ask me for the dimension that I want. I'm going to just start with a 50 millimeter dimension. Again, I don't know exactly how big this is going to be. I know I have the product here with me, but I guess what I'm saying is at the beginning of the design process, we don't know exactly how big it's going to be. So we'll just assume 50 for now, and we'll make sure that we build intelligence into the model so that we can make the changes to these dimensions later, and it won't cause us a headache. So we'll start with 50, and that's good. Now here's another tip that I want to give you is instead of hitting escape to get out of my dimension tool, or coming over here to the confirmation corner to exit my sketch, or even using the D key to exit my sketch, I'm going to do something different. I'm going to go straight to the Features tab and hit Extrude. This is a nice shortcut because we can skip a couple of steps and we go right into extrusion. So that's really nice. Now I do want to point out with this product that the top is maybe a little bit thinner than the bottom. So let's just say the top's going to be 5 millimeters for now. And we'll extrude in a second direction as well. We'll make that 10 millimeters, and then we'll say check to confirm. I'm going to grab my S key here for my fillet tool. I'll select this vertical edge. I'm going to use this convenient pop-up here to select the other vertical edges as well. There's another one here, but I don't want all those edges. I just want the vertical ones. And that looks pretty good. That looks pretty good to me. We'll use the D key here and say OK. So now I have kind of the start of my part. The corners and stuff need to be rounded off a little bit, but we'll get right into the first method of master modeling techniques. Actually, something that I didn't do. This is a big no-no. I should have saved this part. So let's go ahead and save this. I'm just going to put it in a folder here. Let's call this master. Okay. So now that that's saved, I feel a lot better. We want to make sure we save early and save often, of course. So, all right, so let's get into the first method of master modeling techniques, and that's the split command. So I don't exactly remember where the split command is, but that's okay. I'm going to use my search commands. Again, that S key on my keyboard is really useful here. If you look at the top right corner, you can see there's a blinking cursor there. That's telling me that I can start typing. So I'll type split here, and it'll filter down all the commands and just to the ones that have that in there. Now I could hit enter and just use that top command, but if I want to know where it is for later, I can just use this eyeball here and it's going to show me exactly where that tool is located. There we go. So it's buried in this menu under split. So I may want to add that to, if I use that often, I may want to add that to a context toolbar or something like that. But for now, I'm only going to use it this once, so we're good. Now in the property manager, we need to choose a trim tool. I'm going to use that same top plane that I used before, and I'm going to choose cut part. Now the way that this master modeling sort of works is that you start with just a big single part file. So I'll use my Xbox controller for this example again, and then you kind of chop off pieces as you need to get to the to make these changes on these. So you'll have a main big part, then you'll have individual parts, and then you'll bring them all back together again for a top level assembly. So that's how that's going to work. Now the thing I don't necessarily like about this method is that you can only use a plane or a surface, so you can't really get super complex with it. With that remote, it's going to be relatively complex as far as how that split is done, and it's going to have multiple parts come off of it. So for example here I have these buttons on the top that I also want to consider, and this split tool isn't going to be able to save out all of those bodies for me in one command. It can really only do one thing, so it's fairly limited. However, it does have its uses. So I have an example here of where that might be very helpful. Okay, so this is just a handle and it's split into two parts, and then you after you split it, you add the manufacturing information in there. So as far as master modeling tools, I don't necessarily recommend this one. It has very little options here, so we're not going to choose it, but it is very useful for splitting the part into if I need it. So if I click on the scissors here, it's going to split the part into two, and I'll say check to confirm that. Now I have two solid bodies in my model. This is something that Solidworks does really well, which is multi-body modeling. And so I can tell there are two bodies because if I expand my solid bodies folder, I see 1 and 2. And also in SolidWorks, if I want, I can hover over either of them and hit the Tab key on my keyboard and it disappears. If I want to get it back, I can do Shift Tab and it brings those back. So I have 2 separate bodies in here. Okay, so before we move on with the design, I'm just going to come over here and check out the chat real quick, see how we're doing. Hello from France. Well, hello. Thank you for joining us. We appreciate that. Waiting for the tips from Infant Nelson. I hope I've given you a couple of good tips so far already to increase your productivity. Can we go over rendering tips in another video? I think we definitely can. So we will definitely put that into the bucket. All right. So people are asking for animation and visualize. Those are great tools to use, and we will definitely consider those for a future one. Thanks for the comments. Okay, so let's continue on with our model here. So we're back here into the model, and what I want to do is, if we look at this part again, we can see that. Well, let me just switch this over. If we look at the model, okay, we can see that it's got this top portion here. It's got kind of a. Sorry, guys. Let me get that focus going right. Okay, so the top one looks, maybe like a symmetric fillet, and the bottom one looks somewhat asymmetric. So, let's take that into consideration. So the top one's going to be somewhat of a symmetric fillet. Now, I'm going to focus on that real quick by hiding the bottom one. If I select this edge and choose fillet, I can go in here and I can say, okay, I want a symmetric fillet. And here's something else that I think is a little bit odd about how SolidWorks does things. If I hit the up button here and I say, oh, I want to increase that fillet by a little bit, it's going to increase it by 10 millimeters. It seems like kind of a lot. So a tip that I learned here in live design is if I hold the Alt key and I click on one of these, it'll just reduce it or increase it by 1 millimeter. So that's a really useful tip. So I can keep reducing it or increasing it. And as we can see, 5 millimeters seems about right. So I'll hit check. However, I was talking earlier about adding intelligence to our designs. So what happens if I click on this face and I use Instant 3D to increase this? Well, now we have this vertical edge here, and that really wasn't my intent. It's not really what I wanted. I kind of would rather that fillet sort of grow if the height of it grows. And again, we know we're going to be changing these dimensions because we're just at the very beginning of our design process. So let's get rid of that. And instead, we're going to try for a different method. I'm going to use the same fillet tool, but instead of using just the constant size fillet, we're going to head over here and choose the face fillet. Okay? Now, I'm going to talk about these boxes here real quick. When we see blue in one of these boxes, what that means is that SolidWorks is expecting us to click on something and fill that box. So that's the active one. So I'm going to select one of these faces. And notice, we really want to pay attention to the cursor in SolidWorks because it's always giving us a lot of feedback. So notice my cursor has this return carriage on the right mouse button. So what that means, if I hit that return carriage, my property manager shifts over to the second box, which means I can immediately go here to the top face and select that one. So that right there can save you a lot of time. Instead of traveling your mouse back and forth, just look at that cursor feedback and use that to your advantage. Okay, so now it looks good again. However, we're still looking at a symmetric fillet at 5 millimeters, and that's really not what we want. So let's kind of zoom in over here, and I want to show you something that I really like, which is this hold line. You may have not seen this before, maybe you have, but this is something that can really change how you deal with fillets. So I've got this hold line selected, and now I have another blue box here. It's asking for a hold line edge. So if I just select this bottom edge here, again, notice it hasn't really done anything out of the ordinary. It looks exactly the same. I'm going to use my right mouse button here to confirm that. But the difference is when we try to increase the size of this again, notice what happens. Notice that the fillet grows as we increase or it shrinks as we decrease. This is the type of behavior that I was really looking for. So that hold line can be really useful. Okay, let's finish this off by adding a fillet here to the bottom face. Again, I don't want this to be symmetric, so we'll choose under fillet parameters, we'll choose asymmetric. And then here I'm going to use my Alt key to increase or decrease this until I get something that I like. So let's say about right there looks good. So we'll say a 7 millimeter fillet in that direction, 10 millimeter in the other. And that looks about right, I think. Okay. So I'm going to head over here to the comments. Okay, harsh. You want tips for making a French press. My best tip for making a French press, make sure that the grind is correct. You want a conical burr grinder, and you want to make sure that it's set to where like the grinds are pretty coarse, not like sand. That's gonna make a really sludgy and gross French press. So make sure you have the right grind size. That's the best tip. Oh, and fresh roasted coffee is of course the best choice. Surface modeling techniques, please. That's a great request. Check out, I think, live design number 3, where Andy Barnes made a surfboard wax iron, and that was a really excellent one. Take a look at that comment in the description below, and take a look at that so you can see how he used surfacing to create that. Really good one. Hi everyone, I missed too much. If you missed a little bit at the beginning, don't worry. This is being recorded. You can watch it on YouTube later. So, cool. All right. Well, thanks everyone for tuning in. Thanks for all the comments and chatting with me here. Okay, so we're going to continue on with our design. Now, I want to create these buttons at the top. So we have 4 buttons there. They're pretty equal in size. So let's go ahead and add these buttons here. Here's another tip that I like to use a lot. I'll select this top face, and I'm going to choose to sketch on that face. Now notice that the face is still in blue. It means it's still selected. So that means I can perform operations with it. So if I want to offset the edges of that face, I can just simply come to Offset Entities. Okay, now I can choose how much I want to offset it by, maybe 1 millimeter. I'm going to set it to the inside, and then say I want to confirm that. I'll use my S key, grab the line tool. You can also use the L key just to bring up the line tool. That's another quick tip for you. And we can drop a couple of lines on here. Now, I gave you that tip before about don't worry about exiting, your dimension tool or your line tool. Don't worry about coming to the confirmation corner to hit check. You can go straight to the Features tab and go to your feature. However, I use Extrude and Cut a lot, so why not add those to my shortcut toolbar? That way I don't have to do all this mouse cursor moving all over the screen. So here I have Extrude and I have Extruded Cut, and I just use them from here. It's really simple that way. Okay, so I want to extrude all this. It's really important that I only extrude through that top body. So even though I said through all, I really only want it to apply to that top body. So that's what that feature scope is going to do down there. That's really useful. So we do have through all, and I'm not getting a preview. And the reason is because SolidWorks doesn't know what I want to extrude. But here's the trick here. I actually want this to be a thin feature. And notice it's going to take those lines and it's going to create a cut. See this kind of yellow region, it's going to cut with that. It's a little too thick and it's kind of in a weird position. So let's change that to mid-plane, and then we'll change this to, let's say, 0.5. It really should be very thin, and we'll say check to confirm. As soon as I do that, it recognizes that I'm making cuts between bodies. It's making several different bodies. So it's going to ask me, do I want to keep these bodies? I'll say OK for all bodies. And there we go. So now I have several solid bodies, and you'll notice that it didn't cut through the bottom, it only cut through the top. So that's good. Now let's take a look at my solid bodies folder. We want to do some cleanup here before we get into the next method of master modeling techniques. So here I have several bodies. Some of these are kind of redundant. I don't need all of these. So for example, I can just say, let's select those and hit delete, and I'm going to choose to delete those bodies and get them out of here. Now, if I decide later that I want some of the buttons to be larger than others, that's okay. I have this feature here at the bottom of my tree, so if I suppress or roll that back, I can always get those bodies back. This is the power of history-based modeling techniques that tools like SolidWorks use. Okay, so with the rest of these, let's start giving them some names here. So for this one, I'll call this bottom. It's always nice to kind of rename these, and we're going to use this renaming later. We'll call this top, and we'll call this button. Okay. And while I'm here, I might as well add some materials. You may not know, but you can add materials instead of to the whole part. You can add them to individual bodies. So here for the bottom and the top, I'm going to control select those. I'm going to choose a material here. I'll say edit material. And I don't want to do a steel or anything like that. This is in fact a wood, and I'll say, the closest thing probably is going to be maybe mahogany or something. So let's see what that looks like. I'll choose apply, and it looks about right. Okay. Now, if that's a material you use a lot, we've shown this a couple times in live design, but you can go over here to favors, you can add it. Here I have it added. You can move them up or down. You can remove them. So you have a lot of flexibility with that. So definitely, if you're using materials a lot, feel free to add them to your favorites. Let's go to our button material here, and I'll choose, let's say, cedar for that. Apply that, and that looks pretty good. Okay. So we have several different materials here, and I think we're ready to go and show you the second master modeling technique, and that's going to be to right-click on any of these bodies. Let's just save this real quick. Let's right-click on any of these bodies, and let's go to Insert into New Part. Now, when I do this, it says, okay, you can give it a file name, you can propagate the visual properties, you can overwrite the template, that sort of thing. And again, this is just kind of like, we'll call this insert into, we'll just give it a name. And it's okay, but it just doesn't really give us a lot of options. So here we've created that part, we've called it insert into, and let's just to dive into this a little bit deeper, let's take a look at some of the structure of the part. So notice here it does have that mahogany material and appearance. That's nice that it brings that in. And it also has this feature here called Stock Master. If I right click on this, I can find the external references. So here it knows that that this is pointing back to that SLDPRT, or that Solidworks part file in this folder. So that's cool. We can break references and stuff if we want to do that. Yeah, absolutely. Yeah, let's go check out the chat real quick while we're here. So, yeah, I'm seeing body delete, very useful feature, as well as body materials. Thanks, Mark. I see. I would not add materials at this early stage. Visually, it gets in the way of modeling. I couldn't agree more. But for YouTube, it can be kind of helpful. So it's just a little more visual on YouTube, I guess. But anyways, some really good comments there. Thanks, guys. Keep chatting with us. We appreciate it. Okay, so I've got this thing here. So something else I can do is I can edit this in context, and watch closely. It's going to head right back to that part. So these are pretty useful because it helps us understand like where these parts came from. But there's unfortunately no kind of reverse of that direction. There's no information going the other way, and so this starts to kind of generate some questions for us. If I go to File, Find References in my master part, notice that there's nothing here. So this part actually doesn't know that it's been saved out from. It doesn't know that there's a link going back to it. So how would I know if I was just maybe somebody else on your team, or maybe just myself, but a future version of me from a couple weeks from now that is trying to remember what I did with all this stuff? Because I'm not writing down necessarily any notes when I'm going through this. It's I'm just relying on the software to do a good job, and so the problems start coming up. You start thinking, okay, well, what happens if I accidentally move this file, and now all of those child parts don't know where the master model is anymore? And that's a really relevant question. So we're going to talk about that a little bit more here in a second. Okay. So method number 3 then. Let's move right into method number 3, which is personally one of my favorites. So if I right click on the solid bodies folder, rather than one of the individual bodies, I have this option here called Save Bodies. So when I select that, notice what happens. It gives me kind of this floppy disk here that I can just click on, and it's going to automatically get these names. It's going to allow me to propagate the visual properties. It allows me to choose an origin location. And this is really interesting. It allows me to create an assembly. So if I say, let's call this Save Bodies, for example. We just save that, okay? And there we go. So now it's going to create an assembly for me, just like that. So if I hit check, we'll see what it does in the background. And there we go. That was pretty quick. So that actually was really, really amazing because it kind of took our insert into new part workflow and put a bunch of those together and then added some extra features to it. So that's really useful if you have to do this for a lot of bodies, for example. Again, this remote is a relatively simple example, but once we start to get into something a little more complex, this type of method is going to be really useful. Okay, so let's take a quick look at the structure of what I did here. So I have something that's different than any of the other methods, which is a feature in my feature tree. And I can actually edit this, and I can see that I've exported these several bodies into these files. It doesn't tell me exactly where they are, but it actually gives me an indication that these have been exported. And that's really useful. Again, kind of considering if you're collaborating with other people, and collaborating with other people can mean different things. In effect, you're collaborating with yourself, just the future version of yourself that may not remember everything that you did today. So, there's this save bodies feature at the bottom of the feature tree. So that can be really helpful as sort of a reminder or a prompt that somebody has saved out external bodies to this. So we might want to be careful about how we treat this file. Something else that we can do that's interesting with this is that any features that are made underneath that save bodies feature don't get propagated to the child parts. So for example, let's create a sketch here. I'm going to use my offset entities command. We'll reverse that direction. We'll say 3 millimeters is what I want, and I'll say check to confirm. And let's use my S key to create a cut. And I'm going to build intelligence into this again. I want to core out this material. So let's take a look at, let's again sort of take a look at this. For that circuit board, there's a little bit of a cavity in here, okay? So we're going to cut out that cavity. It goes into this part a little bit, and it goes into the top part a little bit. So we're gonna cut out that cavity right now. However, I don't want to just choose a depth. So right now I'm choosing blind, and it's just going to go into the part whatever amount I specify. So really what I'm looking for to build intelligence into this part is use offset from surface. I'm going to select this bottom surface, and now when I say I'm going to go and change this to 6 millimeters, 7 millimeters, notice that it's shrinking instead of growing because it's offsetting from that bottom port by a little bit. So we'll say 3 is probably fine here. But I don't want to hit check now. I want to actually extrude it in the other direction too. So let's go to direction 2, and we're going to do the same thing. I don't want to just blindly extrude it. I want to go to offset from surface, select my top surface here, and then we'll just minimize that to whatever we think is appropriate. Maybe, yeah, 2 millimeters looks good here. So we'll hit check to confirm, and now those have come out. Okay, so let's kind of talk about what's happening here. So I have a cut extrude. It's underneath my save bodies feature in my feature tree. So I'm going to pan this over here to the right, and let's take a look at the save bodies assembly that was created with those parts. Notice that nothing has happened to this yet, although it does contain all these parts in here. If I take this cut extrude and I just drag it up above save bodies, nothing has changed here, but if I head back over to my save bodies assembly, notice that all those parts get updated, and now we have our assembly complete with that extrude in there. So this save bodies method is extremely powerful, and I highly recommend it. However, there is a better way, in my opinion, and it's something that I really enjoy using, and we're going to get to that here in a second, right after I do some cleanup. So I'm going to say don't save on these. I'm just going to kind of get back to square one here. So let's just rewind. All right, we'll delete our save bodies, and let's just kind of get back to square one here before I go into that new method. So those were the 3 methods, by the way, that I wanted to kind of talk about. This extra one's a little bit kind of special to me. So, but before we get into it, I wanted to mention that I didn't come up with this off the top of my head or anything. I'm not that cool. So this actually comes out of this book. This is called Advanced Part Modeling, and this is my book from several years ago. But this is really a great manual here. It's made by us here at Solidworks, and it has actually all of this information in just lesson 2. So all of this stuff that we were kind of talking about that's relatively advanced, this is only lesson 2 of this book, and so there's a lot of really amazing stuff in here. Now, this book isn't just something where it's only good to increase or improve your skills in SolidWorks. If you're thinking about getting certified as a SolidWorks professional, CSWP or CSWE, it would be really important for you to get trained on this stuff. This comes directly from us, so it's going to be the best training you can get. So where do you get this book from? Well, it doesn't come from. You can't just buy it. So let's head back over here to my web browser and just want to show you guys that you want to reach out to a reseller, and they're going to be able to help you out with this. They have a really amazing training, and they do a lot of the same kind of training that a lot of what I'm showing you today, a lot of tips and tricks, but also showing you exactly how these methods work and what's the best method for you and your company. So so you can go to solidworks.com/find-solidworks-reseller, and you can kind of just zoom in on your area. So I'm here in San Diego, and there's a couple of resellers here that I can reach out to if I wanted to get some training on that, for example. So so definitely make use of them and reach out and see if you want to get some of this training. Is really excellent. So okay, let's check out some of these comments. Keyboard shortcuts. Yes, those are that's a great comment. What's a good keyboard shortcut? Oh, you see me use the S key a lot. You've also seen me use the D key. Those are really good ones. I use the spacebar key a lot to change my views. Those are all really good ones. I use the L key a lot for line. So those are just a handful of good keyboard shortcuts. Yeah, NDC, thanks for your time. Would my local rep be a good starting point of contact for educational version? Of course, yeah, absolutely. Reach out to your resellers if you're interested in educational version as well, and speak with them. I'm sure they can get you set up through whichever educational institution you're currently attending. So, okay. So I have a lot of questions here. All right, so thanks again, everybody, for participating with us in the chat, and thanks for everybody on the team that's helping me out answer some of those questions. So, okay, so the last thing that we're going to talk about is my sort of last method for master modeling techniques. And again, your resellers can help you out with these techniques too. So let's head back here, and we're gonna get right back into the design. Now this one is maybe a little bit more complex, but you'll find that the benefits far outweigh any little additional complexity there might be. Okay, so let's start. We're going to choose a new file. We're going to call it part millimeter. Okay, and there's nothing in here, of course, not yet, but we're going to go to File, Insert, Part. Now we have this part here. It says Master. Okay, so that's good. It's not an individual body, but there are some really great options here for us to look at. And this is why I love this method so much, because if you look at this, we can transfer solid and surface bodies, axes and planes, cosmetic threads, coordinate systems, absorbed and unabsorbed sketches. So this is really the big one right here. This is incredibly important, especially for some of these master modeling techniques, because in the individual part files, when you're creating those manufacturable features, sometimes you're going to really need to go back to the original master model and make sure you're making references and relations to those sketches that you had in the past. So those are going to be really useful, and this is something that wasn't available in any of those other methods that we discussed so far. There's other things here as well. The material, you can propagate the visual properties from the original part. And then something else I really use a lot is this break link to original part. So instead of in the other methods where you had to sort of go find where to break the link, with this method you could just choose to do that right away if you like. Now in this case we don't want to do that. We'll just propagate the visual properties, and we'll grab certain things, so solid bodies, axes, absorbed sketches, and confirm that. Okay, so now we have this in here. Of course it looks exactly like the master part, but we really only want one of the bodies. Well, that's simple enough. So here what I'm going to do is open my solid bodies folder. I'm going to select the body that I want to keep. So in this case, let's say it's the top. And then, and it's going to sound crazy, I'm going to hit the delete key on my keyboard. However, that doesn't mean I necessarily have to delete that body. I can also choose to keep it. It's a little counterintuitive, but it's really fast and it works. So there we go. So now we have top, and we're going to save this part. Okay. So let's head over here to my work. I don't need these files anymore, so I'll just let's override them. That's fine. Yep. So there we go. Those were from the previous master modeling technique. So we'll just overwrite that, and there's no problem. So I have top here, and we're going to do that again. We'll say new part millimeter. We just have to do this once for each body. We can go to File, Insert, Part. Oh man, this is like so annoying to have to go and do this in this menu. It would be so much easier if I could just do a quick shortcut. Oh, I put one right here. Look at that. Insert part. You can just add this to your shortcut key. So this is the type of stuff that really makes this super fast. Okay, so we're going to propagate those visual properties, bring that in, head over to our solid bodies folder, select the body we want to keep, hit delete on the keyboard, keep bodies, confirm. Let's save that out. And this one's called button. We'll just overwrite it, no problem. And then we got one more to do, part millimeter. All right, and then we'll do our S key, insert, and propagate the visual properties, check. Let's expand the solid bodies folder, keep that body, check, save it, and this one's called bottom. Okay, so we have all those, and then the last step, of course, is that we want to create an assembly out of this. We don't have to do it right now, but it's useful to go ahead and get it out of the way. So I'm going to use my drop down here next to new, and I'll say make assembly from part. I'll use my millimeter template, and then here all I'm going to do is just hit this green check. It's going to pull that in, and it's going to fix that body and put it near the origin. We'll just keep doing that, rinse and repeat. Here's the button, check to confirm. Here's the top, check to confirm. And there you have it. We save that. Okay, let's call this, we'll call this remote, and then that's done. All right. So now we take all of this that we went through. We talked about, how we start with our master modeling process. We have a thought in our head. Sometimes we do some sketches. Of course, these don't have necessarily any dimensions in them. And eventually, we need to go through our master modeling, which we just did. And at some point, we're going to need to make some changes to this. So for example, let's say we got our circuit board in, okay, and then, that's going to be a certain, width. So let's just measure that. All right. So we got that. Okay, so that's looking like 37 millimeters or so. Okay, so we got that in there. That's great. And let's say we want 37 millimeter circuit board, and we need a wall thickness. Let's say we want a wall thickness of what is that? 4. So we got a wall thickness of 4 millimeters. Let's see if I can zoom that in. There we go. So we got a wall thickness of 4 millimeters, and so we can just take this information, and we can just go back to our master model. So let's head back over here. We've got our master model, and let's just pan these left and right. So on the left side I have my master model, on the right side I have my assembly, and so what we want to do is we just want to make those changes. So and let's grab an overall as well. So overall we're looking at maybe about 52 millimeters. So we weren't too far off. So we've got 52 millimeters. So we'll just put some of these in here. So there's 50. We'll say 52, and notice that increases that. We have the 4 millimeter wall thickness. So we can take this. We'll say that's going to be 4, and we'll change that. So these are kind of little changes. How about the thickness of the top part? There we go. Okay, so the top part is about 7 millimeters or so. So we've got that as well. So we'll change that here too. Let me zoom in so I can grab that edge. Okay, and we'll change that to 7 millimeters. So that's probably the biggest change here. Okay, and we've made all those changes. Now again, what we're going to see is once I open up remote, it's going to propagate all those changes through the parts and go to remote. There we go. So that's pretty amazing. We were able to build intelligence into this master model so that any kind of changes that we make propagate to those parts and eventually into that assembly. Okay, so we went through 3 different methods of master modeling techniques plus an extra one, and I was talking about it initially, what is the secret to the best designs, but I haven't shown you that yet. So we're going to talk about what I think the secret to the best designs is here in just a second. Let me take a look at the chat. Oh, my mom says hi, Mark. Hi, Mom. Okay, cool. Great. Awesome. Thanks everyone for joining us here in the chat. Okay. Yeah, KCB, internal virtual components and assemblies, is another functionality that feels grossly underused but provides so much benefit in the conception phase of a design. Absolutely. I use virtual components all the time. It's great because those virtual components only exist within inside that assembly. So you don't actually have to create a new part file, which is something else that you have to think about. You have to kind of, and this is a great segue into what I think is the secret to the best designs, and that is, how are you managing all of these documents? How are you managing all these files? Unfortunately, what we saw here with SolidWorks is that, some of the parts understood each other a little bit. But when we look at, let's say over here, if I look at this button, I say, okay, let's open this one, all right, and I have this here. If I look at, for example, the references, it has no idea that it's inside that assembly. Or maybe it could be in a bunch of different assemblies. I mean, if you're working in a place, maybe you make a bracket and that's used in several different projects, you can't just look here and find that. You have to go somewhere else. And so that's really the secret to the best designs, is managing these files well. So let's do something here real quick. Let's say, okay, I have this here. I'm going to make a quick configuration. I'm going to add this one too. Let's add another one. I'm going to call this up. Say check. And oh, I forgot to talk about this. I just want to drive this point home. Notice all these sketches that are in here. So again, this is kind of the power of that method that I was just showing before. But let's do a quick sketch here. We'll grab our line tool, drag a line in here, and I actually want that to just be a center line. Let's do a slot. There we go. Got a slot in here. That looks good. And I'm going to select all these, and we're going to mirror those entities there. All right. Let's dimension these real quick. Say that's going to be 45. Let's make this. We'll make that 1. We'll make this 10, and we'll make this. Let's say 2, something like that. Okay. And again, we'll go and use our shortcut key to grab our extrude, and we'll make that 0.5. SolidWorks right now doesn't know exactly what I want to extrude because there's 2 overlapping regions there, so I'll just tell it what I want, and there we go. So we have that. And then we can use this tool to go around. Just want to finish up this design real quick. Let's do a symmetric and 0.5. That looks good. Okay, we'll save that. All right. Last thing I want to do, I forgot to finish up my assembly here, of course. So I want to, do a pattern of these parts around. This would be the last step, and then we'll talk about the last bit here. So I want to do a circular pattern. Of course, we need something to pattern about. So I'll use my right plane and my front plane. And I'll come over here to reference geometry and create an axis here and hit check to confirm that. Now notice that axis is still blue, so that's selected, which means I can use that for stuff. So let's use this drop down under linear component pattern. I'm going to choose circular component pattern. Notice that my axis has already been pre-populated into this first field. Now I just need to figure out what I want it to pattern. We'll choose that button and we'll say that's good to go. Okay, let's change our configuration here. Let's say this one's going to be the up button. I just select that part, use this drop down, I can choose that configuration and hit check. Of course, because I was the seed, it's going to propagate that to the other ones. I didn't actually want that to do that, but that's okay. I'll use a control select and then I can change all these back to what I want. So, all right, that looks pretty good, I think. So, okay, so we've got that. I'm going to save everything. Save early, save often, of course. Okay, so we're done with all that. We've completed this, but let's talk again about that secret to the best designs. Keeping track of all these references and all these files can be difficult. Windows wasn't really built with CAD data in mind. It wasn't really built with having these back and forth references in mind. So we have tools now, PDM tools, that have been built out of this problem. We want a way to be able to manage these relationships, keep everything stored in a secure place, and facilitate our projects so that we can get to market faster, of course. So with tools like SolidWorks PDM, which are freely available to you if you have a seat of SolidWorks Professional or Premium, they handle this really well. I've used PDM for a long time. I really enjoy using that tool, and it's great at making sure that it can keep track of this stuff. Again, if we go to this part here, there's no way for us to tell where this thing is being used. It just doesn't know. It only knows that it came from this master model part, but that's it. That's all the information we have. So what I like to use now is the 3D Experience platform. So I have, let's go to our assembly here, excuse me. So I have just this little tab here, and I can right click on this and I can save this to this platform. So I'll just hit save here. And what this platform is it's a cloud-based, secure. See, it's asking me for my password here. It's asking me for it's a secure location where not only can I store. I'm sorry, folks. Okay, I know you don't want to see me type in my password 8,000 times, so I'll try to do it right the second time. So it's a place where we can store these files. It's secure, and we can choose, where we need the files to be stored, and it will load them up there. This makes it accessible to everybody on our team immediately. Now, the thing with PDM, it also has this functionality, but that server sometimes has to exist inside your office. So for this solution, it's actually a cloud-based solution, and it allows you to do a lot of the same things. You can reserve components for yourself to make sure you don't get accidentally overwritten. So only one person can be making changes to a part at once. However, the rest of the team, of course, can view that part if they want to. It also has things like revision management so that you know what is the latest, most up-to-date information, and you can have an understanding of all that at all times. It also keeps track of all of those references that we talked about before. So let's talk about the 3D Experience platform and what that looks like. So here I've just loaded it up. We've got our files in here, and let's go back to that button part. And I'm just going to drop it into this viewer where I can find where this thing is being used. And it's going to pull this open, and we have a very graphical layout of that button and its relationships. So we can see here that it knows that it's being used in that remote assembly. It also knows that it came from this master model, and it has some other things here which are kind of curious. So what are these? Well, if we drag and drop these into our viewer, we can get an idea of what these are. So we'll let that load up. So this is kind of like e-drawings, but is available on the platform. So we can drag and drop files in here and see what these are. So these are, of course, the configurations that I just made of that part. So, just a simple drag and drop here, and we can see those. And it's pretty cool. I mean, you can expand this. You can do other things. You can do, like, hey, we need a second arrow here. And then we can send this to our team. We have this. I'm not going to show you. There's so much stuff in the platform. I wouldn't want to show you everything in here right now because we're about to run out of time. But you can take a screenshot and post it to your community, which is sort of like a Facebook feed, but for your company, which is kind of neat. So I think that's really cool. And we can dig into these parts, and we can drag and drop, let's say, the assembly in here. And we can do, what else can we do? We can do like a exploded view like this. I didn't create this exploded view in SolidWorks, but like it understands the software. It understands the files that SolidWorks makes, and it can do stuff like this just automatically, which is really cool. So, so again, not to get into what the platform does and everything too much, but I just wanted to kind of show that. So to me, again, this is the this is what makes designs great, is having, organization and understanding where your files are being used, and making sure that, you have a system in place that keeps things from happening that you don't want to happen. Before I used PDM, there would be times where I'm collaborating with people and we'd be using a central network drive, and I would save my changes to it, and then they would save their changes to it. And later I would say, where did my changes go? Well, their changes overwrote mine because they saved it after me. So with a tool like this, you can reserve or check out components, and then that doesn't happen anymore. So there's all kinds of benefits to using a system like this, but I just kind of wanted to go over that quickly because it's something that I really believe in, and I think either Solidworks PDM or the 3D Experience platform are excellent tools for getting that done. So, okay, cool. So that is, we're just about out of time. And again, thank you so much for tuning in. I really appreciate everybody in the chat. Hope everybody's staying safe out there. And if you don't mind, give us a like, really help out our channel here, and also subscribe and hit the bell icon. That way you'll be notified of future videos. So for example, next week, Tandy Banks is going to be doing a live design right here. And it's going to be at the same time, it's going to be about using sheet metal tools inside SolidWorks to create some DIY projects around the house, which is going to be really cool. So I'll definitely be there to chat with you guys, to answer questions and stuff as well. So I'm looking forward to seeing everybody there as well. So thanks again, everyone. And if you have questions, of course, you can chat them, but you can also leave them in the comments below the video. So thanks so much, everyone, and hope you have a great weekend.